All right, so we're going to do connective tissue next. We've made it through epithelial tissue. Hopefully it hasn't given you too much trouble. And now we're going to go over connective tissue. A lot of times this is what's going to underlie the epithelial tissue. All right, so the first one is areolar connective tissue. This, you can see it's a gel-like matrix. This is really going to underlie a lot of the epithelial tissue that we just looked at. I'll show you. It has an extracellular matrix that's made up of what we call ground substance and these fibers, collagen fibers, elastic fibers. So this gives us a lot of stretch to it, the elastic fibers, a lot of basically just oomph in terms of collagen structure. This is very widely distributed. I gave you this. I mean, it's mucous membranes, organs, capillaries, a lot of different places. If you take a look at this, you can see the fibers, and you can see the bigger collagen fibers and the tiny elastic fibers that allow it to stretch. And then you see the fibroblasts, which are the cells of this tissue. Okay, so this is what underlies a lot of the epithelium. So underneath your skin, you've got areolar connective tissue, and you're going to see this a lot. Another tissue that we're real familiar with is fat, but in medical terms, we call it adipose tissue. All right, and so this is the cell. And what it happens here is as the cell fills with fat, it pushes the nucleus of the cell up against the membrane of that cell. So these are all full of fat, and you can see the little nuclei up on the edges. And these cells are called adipocytes. So again, this fat tissue is going to provide a reserve for your fuel. If you run out of sugar, if you run out of your carbohydrates, this is your second source of food. You're going to start utilizing fats. You're going to start burning fats. This is also a great insulator against heat loss, that sort of thing. You know, a lot of our mammals that live up in the, polar regions, they have that nice layer of fat that protects them. So this is very protective. We have a lot of fat layers around us in certain areas to protect organs. We have a fat capsule around our kidneys. We have fat around the bigger vessels just as a protective layer. All right, so very nice protective layer. All right, the next one is dense regular connective tissue. This particular one that you're looking here is actually a picture of a tendon. So you can see this. We have different kinds. This will attach muscle to bone, muscles together, bones to bone. But because of the dense packing of this tissue, basically what it allows for is a lot of pressure, a lot of pull. You can put a lot of strength, and if you sit there and you move that shoulder, you move that hip, this will withstand a lot of stress on that joint. So this is what most of our tendons are made up of, our ligaments, but this gives us a lot of strength to those joints so they don't pop out. What you want to look for is this very dense tissue, these very long nuclei, and a lot of times with dense regular tissue, and I try and pick this out for you on your test, you see these little waves. All right, another one is reticular tissue. Now, reticular tissue is very unusual. It's found in your lymphoid tissue, your lymph nodes, the bone marrow, the spleen. What it does is it provides a network of fibers that blood cells can hang on to. So for example, we have reticular tissue in our thymus, which is right in our chest, right below the manubrium of the sternum. And what it does is our little lymphocytes, our particular cells, T lymphocytes, migrate to that thymus gland and attach there. And they have to be attached to these fibers in order to grow. and they get secreted by this this growth factor secretes on them, and they grow and they mature. So what connective tissue really does is provide these fibers that these cells can attach onto. And if you look at this, these cells are white cells. These are lymphocytes, and they're attaching to these fibers. And it just provides a nice skeleton for them to attach to so that they can be there. Hyaline cartilage. This is cartilage. There's different kinds of cartilage. I've picked hyaline cartilage. There's elastic cartilage. There's other cartilages. But this is found generally at the ends of our long bones. Like if you eat a chicken bone and you eat it down to the bone, that little white covering over the end of the bone, that's cartilage. That's your hyaline cartilage. When you look at it, you have these little pockets in the tissue. These pockets are called lacuna. Inside the lacuna are the little cartilage cells. Cartilage, we use the prefix chondro. So inside the little lacuna are chondrocytes. Cyte meaning cell, chondro meaning cartilage. So if you have cartilage, you have a pocket, and inside that pocket, inside that lacuna, is the chondrocytes. You have the matrix with the little lacuna with the chondrocyte in it. What this does is obviously give you cushioning. It's very resilient. It resists stress to those bones. It forms most of the embryonic skeleton as I've got here. It's going to cover those long bones. It's going to form the cartilage in the ribs, in the cartilage of our nose and our trachea and our larynx. So there's the costal cartilage. But we're going to talk about bone, and we're going to have the same lacuna, but the bone, it's going to be a bone cell in here, an osteocyte rather than a chondrocyte. So remember, anytime you're dealing with cartilage, you use the prefix chondro. All right, here's a little bit different. Look at it. You can see the hyaline cartilage. You can see those little lacuna. You can see that cell in there, that chondrocyte. A lot of these, particularly in the trachea, have a fibrous layer on the outside, and that's called perichondrium around the cartilage. Okay, so you do have a layer of tissue that surrounds that cartilage in some places. All right, so now we're going to get to bone. And we have two different kinds of bone. We have this hard, compact bone that most of us are familiar with, and then we have the inside of the bone that is actually what we call spongy bone, trabecular bone, cancellous bone. We have several different names for it, but it's not this hard, compact bone that you think of. All right, it has spaces, and we'll take a look at it in a second. So the structures that you see in here, the pink structure is called a trabeculae. That's where you get the name trabecula. And this allows these blood cells. This is the bone marrow that makes your blood cells. This is where it is. So this is where the bone marrow is located. You have the trabeculae. You can actually, if you look, you can see these little dots. That's actually lacuna with osteocytes in there because it's bone. Okay, but this makes up the central part of that bone. So let's look at this. You can see this is a nice cut through the bone, and you can see this is the compact bone, that hard bone that we're going to look at in a second along the edges, and in the middle is this trabecular or spongy bone, and this is where that bone marrow is. Okay, so now if we look at the compact bone portion of that bone, it is called compact bone or osseous connective tissue. Okay, and when we look at it, it looks like little tree rings. When you look at this, each tree, if you will, each tree trunk is called an osteon. And you have these little concentric rings, okay? And then you have a central canal, all right? So what you have is, and we'll talk about this when we get to the cells, but you have this central canal where the blood is being moved in, and then the cells begin to move out and lay in these layers. Each concentric ring around the central canal is called a lamella. Okay, and this pocket is the same pocket, the same space that you saw in cartilage, so it is a lacuna. Inside that lacuna is the osteocyte. This is a bone cell, this is not a cartilage cell, so it is an osteocyte. You also see little tiny lines going from the outer portion of the bone cell to the inner portion, these little canals. They are called caniculi. All right, so we will talk about these when we get into the skeletal system. We talk about the structure of bone, but you do need to know these. So this is the hard calcified matrix of the bone. It's going to provide support. It's going to provide the structure of the body. It stores calcium. It stores minerals. We'll talk about this. This is our storage facility for our calcium. It stores fats. All right, most of you don't realize it, but by the time you're 20 years old, you've replaced at least half of your bone marrow with fat because you don't need it anymore. All right, so we'll talk about this a little bit later on. All right, and that's a little close up, and you can very clearly see each osteon. You can see that central canal, or the Haversian canal. Sometimes you may hear it called that. You can see each of the lacuna, which inside is the osteocyte, and you see the lamellae, these rings, and you really can't see the caniculi too well on this one because it's so magnified. All right, and then we're moving to our last connective tissue, and this is blood, or our liquid connective tissue. Now, for this course, you only need to know the 3 basic cells. When we get to AP2, you're going to have to learn the different types of white cells, okay? But for this course, you only need to know the names of the basic cells. So when I look at blood, the cell I see the most of are these little red donuts. Those are your red blood cells, or erythrocytes. Erythro meaning red. That's the Greek word for red. So this is red cell. On the test, you've got to say erythrocyte because that's the proper name. Now, most of the time we call them RBCs, but for this test, you need to know the name. Then you see 3 larger cells. All right, these are leukocytes. These are white blood cells. All right, and when you get to AP2, you're going to learn that these are eosinophils. But that you don't need to know that for now. So when you get to AP2, you're going to have to tell the difference between this cell and this cell, which are different types of white cells. And then last but not least, the thrombocyte. This is actually not a full cell. The actual cell is a megakaryocyte, but it has been broken into pieces, and what is left is what we call the thrombocyte or platelet, and it is these little tiny cells here and here and here. Okay, so that concludes connective tissue, and on to muscles.